Welcome back. Batch processing. It's not just like a relic of the past, it's a vital tool powering businesses and industries worldwide. From payroll systems to generating end of day reports, batch processing ensures large scale data gets handled efficiently. But how does it work? What does it matter? Or what makes it unique and why it is still relevant today. Let's dive into into it and know more about batch processing. So first, let's try to answer the question of what is batch processing. So batch processing is a method of handling data in bulk. And instead of processing each piece of data immediately, batch processing accumulates it over a set of periods like hours, days, or even weeks, and process it all at once at scheduled intervals. Like the key characteristics, we have four things we want to talk about when it comes to key characteristics of the batch processing. The first thing that we want to talk about, which is the schedule execution, like jobs run at predefined items like daily, weekly, or monthly. The second thing we need to talk about, like high throughput. It handles large volumes of data simultaneously, making it highly efficient. Other thing, which is latency, because there is a natural delay since processing only happens after data is collected. And lastly, the consistency. Every batch ensures the data set is processed cohesively, maintaining data integrity. Okay, so let's try to understand how. Let's take an example of how does it work. So we will have like this one. Um, let's make it white and make it like kind of thick, which this will represent our data. Like here, let's make it here like our data arrives. Okay, and it will be processed in bulk. So we have our data. So first we have like first element, first data, and maybe the second. Oh no, delete this. What is going on? Second, maybe third, maybe you have all of this data, and this data it will be like accumulates over time, and at a schedule interval, it will be it will be sent an output, but this output will be delayed output. Uh-huh. So we have here a delayed. Oh no, we have like a delayed output. Okay, so let's try to understand how does it work. So first we have something we call um, let's put this as an example, and let's make this with numbers and make it to the left. The first we have the data collection. The first thing we have data collection. Like first data is gathered over time and stored. This storage could be like a buffer or a database, or even a distributed data warehouse. After that, we have a pre-processing step. The pre-processing, it's basically next we should like the collected data undergoes like preparatory steps like validation, cleaning, filtering, or aggregation. And this is the pre-processing. Basically, we have like a preparatory steps to prepare the data. This ensures data is ready for main processing phase. The next thing we have the batch execution. Here is where the magic happens. The batch of data is processed in one go. This might include running complex computations, performing ETL, which ETL extract, transform, and load operations, or generating aggregate matrix. And we have the fourth step will be post processing. Like after execution, the processed data is stored back in a database or sent to another system for analytics, reporting, or further actions. And lastly, we have job completion. So finally, the system wraps up the batch job and prepares for the next run, whether it's the next day or week or month or whatever it will be. So let's try to find a real world examples. Oh, okay, this is from the old video. Let's try to talk about real world examples of the batch processing. And the first thing we will talk about will be the end-to-end day reports. The end-to-end day reports, like banks and financial institutions generate transactions summaries at the end of every day. Also, it's heavily used in payroll systems, like companies processing employee payroll monthly, calculating salaries, taxes, and deductions all in one go. Number three, we have large scale ETL tasks, like big data frameworks use batch processing to extract, transform, and load data into centralized warehouses for analysis. Um, I think we could talk about like a code example, but I guess this will go out of the scope of this video because the purpose of this video is to only talk about the patching processing on high level. So yeah, I'll not talk about. I will not propose any code examples. Maybe I will talk next about something which is the challenges in the patch processing, and we have mainly four things we need to talk about. The first thing will be the latency, like waiting for data to accumulate means you might miss out on real-time insights. We have the storage cost as well. Here, the storage cost, like patch systems, require significant storage capacity to hold large datasets before processing. And the next thing we have like resource spikes, like batch jobs can create sudden spikes in CPU memory and disk usage, which might slow other operations. And lastly, we could talk about I guess we have problem or challenge in the error handling, because if something goes wrong during processing, you may have to reprocess the entire patch, which is a costly and time-consuming task. There are a lot of frameworks of that using patch processing, like Apache Hadoop, or maybe AWS Batch, or Apache Spark. Spark, not Spark, sorry. So yeah, that's it for this video. So to wrap it up, let's talk about some closing thoughts, like why is patching processing still relevant in today's fast-paced on real-time world. It's basically the ability to handle massive datasets efficiently, ensure consistency, and automate large-scale tasks makes it indispensable for many industries. What's basically, yeah, that's it for this video. And if you enjoy this video, please make sure to subscribe and hit the notification bell so you never miss any video. And see you in future videos.